Good day everyone. Today we are going to solve problems in chapter 7, fluid flow in pipes. So the problem is, in a pipe with a diameter of 0.065 meters and a length of 149 meters, a fluid with a viscosity of 2.87 times 10 to the power of -5 meters squared per second and a specific gravity of 1.2 is flowing at a velocity of 0.72 meters per second. So find the Reynolds number, the friction factor, and the centerline velocity. So first, let's find out the givens. So the given here is meters squared per second. So our viscosity that is given in the problem is in terms of kinematic viscosity. So we will have a given of kinematic viscosity is equal to 2.87 times 10 to the power of -5 meters squared per second, and the specific gravity which is 1.2, and the diameter which is 0.065 meters, and the length of the pipe which is 149 meters, and the velocity of the fluid which is 0.2 meters per second. So now let's solve first the value of Reynolds number. So since the given is kinematic viscosity, we will use the other variation of equation of Reynolds number. So we will have a Reynolds number is equal to diameter times the velocity over the kinematic viscosity. So let's substitute the givens in our equation. So we will have a 0.065 meters times the velocity which is 0.72 over the kinematic viscosity which is 2.87 times 10 to the power of -5 meters squared per seconds. So calculating this, we will have a Reynolds number value which is 1630.66. So we all know that Reynolds number is a unitless value. So since this is less than 4,000, this will be under the category of laminar flow. So now we will move on to finding our B, which is we are looking for the value of friction factor. So since this is a laminar flow and they have their own formula between laminar and turbulent flow for getting the value of friction factor. So since this is a laminar flow, the equation of getting the friction factor is simply equals to 64 over the Reynolds number. So let's substitute the givens. So we will have a 64 divided by 1630.66. So for calculating this, we will have a value of friction factor which is 0.039. And now, since we are done with friction factor, let's proceed to our letter C. So we are looking for the center line of velocity or V sub C. So for getting the centerline velocity, we will have the equation of average velocity is equivalent to 1/2 of the centerline velocity. So in short, to solve for V sub C, so VC is simply equals to twice the average velocity. So substituting the givens from this equation, we will have 2 times the velocity which is 0.72 meters per second. So calculating this in our cycle, we will have a value of center line velocity, which is 1.44 meters per second. So that's all.